velocity. If we use this equation, we can see that acceleration multiplied by time, 1 second, negative 10, plus our initial velocity, is going to give us a final velocity at 1 second of 20 meters per second upward. Remember, it's still positive. The other way to say this is acceleration is the rate that velocity changes. So if it's changing at 10 meters per second, then after 1 second, it'll be 20, after 2, 10, after 3, 0, but we'll see, go on to that. I'm getting ahead of myself. So here's our projectile. We have our velocity is equal to 20 meters per second. At this point, too, our acceleration is directed downward. Let's do that in blue. I like blue better. Our acceleration is going to be negative 10 meters per second squared. That's 1 second. All right, how about 2 seconds? Am I missing anything? I think I am. So let's look at, actually, before I go on, let's look at how far it's traveled in this. So through this 1 second, if we plug our values into this equation, we'll find that the projectile has traveled 25 meters. Our time is 1 second. Our acceleration is negative 10. Our velocity, 30 meters per second. Positive, upwards. Initial velocity, initial position, 0. So we'll find we have 25 meters. Now let's continue for 2 seconds. After 2 seconds, our velocity is now going to be 10 meters per second. It's still positive. It's still going up, but it's still slowing down. Since we're only concerned with the force of gravity acting on this, we're only going to be worried about the acceleration of gravity. Acceleration is not going to change. We still have negative 10 meters per second squared. In this time here, between 1 to 2 seconds, we can find, now we need to change our initial position. If we're going to do that, we'll put in 25 meters, because if we're just concerned with another 1 second here, 25 meters right there, we'll find that our projectile travels only 15 meters in this second. There are other ways to do this. You can use average velocity. You can use there are other distance equations, initial velocity, final velocity, based on those. There are all sorts of different ways. But as long as you know the total thing, your initial conditions, such as these three here, you can find the height at any point. We could just assume that t was 2 seconds and all the way up to there. It would have been a total of 40 meters. Now in this last second here, at time equal to 3 seconds, here's our projectile. It's at the top of its arc. It's up, coming back. It's right here at this point. It's changing direction. Its velocity is going to be 0. And again, this is very important at this point. Just because the velocity is 0 does not mean the acceleration is 0. The acceleration is constant throughout. And in this last second traveling up, we can use any of these equations to find out the distance that it's traveled, and that will be 5 meters. So here we have the projectile traveling upwards. Now we're going to look at what happens as it starts falling back down to the ground. So at 4 seconds, it's now starting to speed up. Its speed is increasing. Its velocity is also going to increase, but it's going to increase in the negative direction. Positive and negative in physics, just to note direction. Positive is to the right or upward. Negative is to the left or downward. Positive x, positive y, negative x, negative y. So in this situation, acceleration still the same. Negative 10 meters per second squared. After that 1 second, the velocity is the same as the acceleration because it's the change in speed per second. So after 1 second, we have a velocity equal to negative 10 meters per second. And it's fallen back down that same last 5 meters. Next, time, 5 seconds. Acceleration. Guess what it's going to be. The same as before. The acceleration doesn't change. Now, what's going to be the velocity? Velocity is still increasing. We have another second. Every second, the velocity is changing by 10 meters per second. So now our velocity is negative 20 meters per second. Final position. Is that on the board? Excellent. We're back at the original height, same as over here. At this point, the velocity is going to be, well, let me start back with acceleration. Acceleration is the same, so we have an acceleration of negative 10 meters per second squared. And our velocity here increases by another negative 10 meters per second. Negative 30 meters per second. Notice that the speed, remember speed doesn't have direction, speed is the same there as it is here for the same height for something launched up. Same height, same speed for something, in this case, in free fall. Now, sorry for that interruption. One last thing. Hang time. Hang time is the total time that an object is in the air. In this case, it's 6 seconds. One very helpful and interesting thing is for a projectile, if it returns back to the same height it's at, half the hang time is where it's at its peak or maximum point. I'll say that one more time. Hang time is the total time in the air. If you look at the total time between for it being at the same height, so for here and here, half the hang time, in this case 3 seconds, is when it's going to be at the top. That's useful for knowing points like at the top, the velocity is going to be 0. I hope this is helpful. Please make sure to include any questions you have in your notebook or take a second and re-watch this. Chapter 2.6 or section 2.6 in your textbook was very helpful at explaining this. Thank you very much and have a good night.